there were some cases like this, if there is a hydraulic jump in between, then do you know how to water surface profile? So like this, in this case, as the subcritical flow would change into supercritical flow would change into subcritical flow, there should be a hydraulic jump in between. So there is, to sketch the water surface profile here and here, you first should know that what are the magnitudes of the depths associated with this scenario. Okay, so you have to judge whether this hydraulic jump will be sketched before the control section, and this is the control section uh, where there is change in slope, bed slope. Okay, so well, you have to think whether this hydraulic jump will be sketched before this control section or after this control section. So uh, if the you can just check this criteria. If y dash is the this depth, is if y dash is less than y normal depth at this section, or on this slope normal depth, there would be some value of y naught 2, and there would be some value of conjugate depth. Conjugate depth means that the depth, one depth would be before the hydraulic jump and the other depth would be after the hydraulic jump. So for this kind of if in we shall ask you to draw the water surface profile for this kind of scenario, and you had to make hydraulic jump somewhere before the control section or after the control section, then you can just show that there can be two possibilities. Uh, as you don't have the magnitude of y dash conjugate depth, and this if you don't have the value of normal depth and conjugate depth, then you can say, since we don't have these values, so there can be two possibilities, and if y dash is less than y naught, then hydraulic jump will be made before the control section. Okay, and if y dash is greater than y naught, then hydraulic jump will be made after the control section. So you need to practice these scenarios and the examples given in this lecture, please.
Excuse me, ma'am. Ma'am, there is a lot of noise in the background.
ओके, मेरे ख्याल में मुझे पंखा ऑफ करना पड़ेगा, मैं पंखा ऑफ करती हूँ. Okay, there is another example which is in the book of Open Channel Flow by Muhammad Hanif Chaudhry, example 5.2. So please check that example also for exam point of view. I have kept this example in these slides also. So you better check the statement of the solution, or you can check the solution of that example from the book, and it states that several. Let me open the example first. Yeah. One is this. This is, I think, not that much difficult, but here are also you have to draw the water surface profile between the critical depth line and the normal depth line. Just remember that each water surface profile would be made between the two depths, that is critical depth line and normal depth line. Okay, depending upon the slope of water surface profile will decide whether the depth will increase or decrease with distance or not. Then you will be either the curve starts from critical depth to normal depth, or it would start from critical depth to from normal depth to critical depth. Okay, so usually yes, from critical depth to normal depth. Yes. And 5.2 is this. So in this example, there can be several water surface profiles possible, depending upon the location of control sections as well as the gate opening. So we may divide these profiles into the following two categories: control at the channel entrance, control at the gate. So for part A, let's consider that control is at the channel entrance. So if the control is at channel entrance, then the channel discharge is not controlled by sluice gate. Okay. This is because we have supercritical flow in part. I'm reading the text written with the question. If the control is at the channel entrance, then the channel discharge is not controlled by the sluice gate. This is because we have supercritical flow in the part of the channel length upstream of the sluice gate. Depending upon the gate opening, several different water surface profiles are possible upstream of the gate, as shown in figure 6A. A and 5.6A and 5.6B. This is A, 5.6A and 5.6B. So different profiles have been shown in both the figures depending upon the gate opening. The flow depth approaches the normal depth line asymptotically since the channel is long. Depending upon the gate opening, S1, S2 or S3 profiles are possible. So there can be three profiles possible with this gate opening, as the gate opening is in the normal depth line, within the normal depth line. So if that is the situation, then due to that backwater effect, there would be S1 profile upstream of the gate. Okay. And similarly, there would be S2 profile here first, and then hydraulic jump would be created, and then S1 profile. So you have to in exam, if you are given such type of question, then you would have to show different scenarios. But yes, in exam, if you would be given the opening, the depth of the opening if sluice gate is provided. Okay. So please read this example from the book, and there are further some questions given in this presentation. Let me. We shall be discussing it after discussing the direct step method. Actually, this question we have discussed earlier, and it is to the method of computation of water surface profile, and one of the methods of computation is direct step method, and this is that method. So we'll discuss that method in a short while. But let me show you some examples I have saved in this presentation. You must check those examples. I have also kept the solution of all these examples in the presentation. So uh, kindly try to do these questions for the practice of it. So there are some questions in which you need to classify the water surface profile, and this is also this question is also related to direct step method. We'll be discussing it in a short while. Yes, this is classify the water surface profile. Uh, Show all necessary calculations. So this kind of question we have already practiced in the previous lecture. So I expect that you will be able to do that. The two most important calculations you would be doing in this kind of questions would be one would be critical depth and the other would be Y naught. And then uh, uh, depending upon their magnitudes, you'll be deciding on the water surface profile type. Okay, so please practice these questions, which are included in the presentation. So again, this is the question. You can check that you have to classify the water surface profile, show all necessary calculations. But they have given us some parameters through which you would be easily calculating the y naught. Y naught is the normal depth or uniform depth value. Okay, so using the normal depth and critical depth value, you can classify the water surface profile. So all the questions are regarding the sketching of or water surface profile or classifying the water surface profile. So same kind of questions are there. So I expect that you'll be able to do that. So here they have asked you to sketch the water normal depths, critical depths, and water surface profile types. So in the question they have asked you to draw the sketch also. So um, and they also have given that there is an abrupt change in slope from this to this. Make a sketch showing normal depth, critical depth, and water surface profile type. So first the slope was mild and then it became steep. Okay, so so where the control section is where there is change in slope, so it must pass through critical depth line. The profile, water surface profile must pass through critical depth line where there is a control section of change, where there is a change in slope. So then you would have to uh, classify it accordingly by just calculating the normal depth again for steep slope. Okay, normal depth again for steep slope using the Meaning's formula. Okay, so there would be two normal depths, one for this slope and the other for this slope. Okay, so in this question you would have to calculate normal depth 2 times. So again, similar type of question is this. Uh, Again, no, I think this is the same question. Slide is being used. Kindly practice all these questions as solution is available to you. So you can easily practice them, but please open the solution after doing it by your own hands. Okay. Okay. Let's check how to compute the water surface profile depth. How to compute the water surface depth, and we'll be consulting the sixth chapter of Open Channel Flow by Mohammed Hanif Chaudhry uh, to just discuss some of the methods which are used to compute the depths of water surface. So that chapter, the title of that chapter is Computation of Gradually Varied Flow. Okay, the topics we shall be discussing in this chapter are as flashed. Okay. For engineering applications, it is necessary to compute the flow conditions in the flows. These computations generally referred to as water surface profile calculations. Determine the water surface elevations along the channel length for the specified discharge. The water surface elevations are required for planning, design, and operation of open channels to assess the effects of various engineering works and channel modifications. The addition of dam, for example, raises water levels upstream of the dam, and it is necessary to know the flow depth in upstream area to determine the extent of flooding. So the no doubt depth calculation, water surface depth calculation is extremely important if you are aiming to do the flow analysis in an open channel. So the equations which are used to determine the depths are the continuity equation, momentum equation, and energy equation, which are related to various flow variables such as flow depth, discharge, flow velocity at different sections of a channel, and we solve these equations to determine the flow conditions. So these are actually the flow conditions, or you can say unknown parameters which need to be calculated uh, when you are doing any flow analysis in an open channel, which are flow depth, discharge, and flow velocity. So yes, you will be using continuity, momentum, and energy equation to find out all these flow parameters. The channel cross section, meaning end channel bottom slope, and the rate of discharge are usually known, and we compute the flow depth and flow velocity at different channel sections in a specified channel length. So let's check the governing equation again. You know that what is continuity equation? It is Q is equal to V multiplied by area of cross section. Then the second equation is energy equation. So energy equation, it is actually the sum of energy at one section is equal to the sum of energy at any other section. So if this is this is the longitudinal view of the river, you can say any open channel. This is bed of the channel. This is water surface profile, water surface. This is water surface, okay, and this is energy grade line. What is energy grade line? The line joining the points of total energy is the energy grade line, or total energy heads line joining the points of total energy head is the energy grade line. So you can see there are three lines. One is the bed, one is the water surface, and one is the energy line. So the difference between the energy line and water surface would be V square over the velocity head. So you can say that from here to here it is velocity head. Okay. According to the energy equation or law of conservation of energy, if this is the datum, any reference line, uh, and if this is the datum line, and it is horizontal. So the depth, the this distance from the datum to this point bed, this would be Z1, and it shows the potential energy at this point. Z1 is representative of potential energy at this point, okay, at the bed, on the bed. Then, or you can say for this section, the potential energy, potential head is Z1. For at section 1, the total potential head is Z1, and then this would be the depth of the fluid in an open channel. At section 1 it is Y1, so this depth is actually representing the pressure head, okay, at this section, and the distance between the hydraulic grade line, or you can say water surface, and the energy grade line is actually giving you the velocity head. So from the datum to the bed, it is Z1 potential head, Y1 pressure head, and this is kinetic head or velocity head from here. So at section 1, if you are considering this as section 1, then total energy would be Z1 plus Y1 plus V1 square over 2V. Okay. So according to law of conservation of energy, energy is conserved. It means that the total energy at one section would be equal to the total energy at any other section in a flow field. Okay, so using that law of conservation for real fluid, you can write the equation, energy equation. So section 1 energy is this, Z1 plus Y1 plus V1 square over 2G, and at section 2, to check the energy, it would be Z2 plus Y2 plus V2 square over 2G. Okay, this is up to here. This is the energy at section 2, but energy at section 2 would be less than the energy at section 1 due to the head losses in real fluid flow scenario. So for real fluid flow scenario in which we consider frictional losses and shear stresses, there would be head losses present. Okay, and so the difference of the energies is actually the head loss. So to write an equation form, we'll write like this, that Z1 plus Y1 plus V1 square over 2G would be equal to Z2 plus Y2 plus V2 square over 2G plus HF. Okay, so writing the this is the equation between section 1 and section 2 in an open channel. Then again, using through this equation, we already discussed that equation in the previous lecture. Through this equation, you get the governing equation, which is how to get the slope of this water surface profile, and this is actually the this equation dy by dx is actually giving you the slope of water surface profile. Okay, so dy by dx can be calculated using this equation, this formula. So as we just call this formula as function of x and y, as this right hand side of this equation is the function of x and y. So we can call that as a function of x and y. dy by dx is a function of x and y. So our aim to use to find out, our aim is to find out the depths of water surface profile. So the same equation can be written like this: function of x and y is equal to s naught minus sf over 1 minus root number square. And okay, so we have this governing equation. To determine x and y, we have to integrate the flow, integrate and determine the flow depth along the channel. A closed form solution of this equation is not available except for very simplified cases, because uh, f function, this function is a nonlinear function. Okay, therefore numerical methods are used for its integration. This method yields the flow depth at discrete locations. So it is very there are many methods available to solve this equation. So we'll be discussing some of the methods through which we would be able to get an idea to compute the water surface depth. Our objective is to get y at different distances in a gradually varied flow. Okay, so, and this is actually the governing equation for that, and there are many methods available to solve this governing equation. Let's discuss the basis of these methods. Let the flow depth y be known at given distance x. Let us denote these known values as y and x respectively. To determine the water surface profile, we may follow either of the following two procedures. So there are two procedures which we can follow to determine the depths. Determine y2 at specified location x2, or you can determine x2 where specified flow depth y2 will occur. So there can be, depending upon these two criteria, there are different methods available to us. So first method is either you know the location, x2 is known, and you have to determine y2. Okay, and the second method is you will be determining x2 where the depth is known. Okay, depth would be known to you, and you will determine x between those depths. Okay, so in both the cases, you would have to numerically evaluate the integral term. By successive application of the equation, we may compute the water surface profile in a desired channel length. So one possibility when the value of y2 is unknown and distance is known. Okay, and x2 is known. Like x1 is x1 is the distance you already know, that would be known to you, and there is another distance which you know, that x2. In between x1 and x2 there would be delta x, and you know the length between the two sections, and you would have to calculate y2. Okay, so then y2 can be calculated after integration and setting the limits between x1 and x2. So this is one of the methods. It is to determine the location of x2 where specified flow depth y2 will occur. That is actually the method we have discussed in the first lecture, and that is, what is that method called? Direct step method. So in this case, this is the same governing equation, but reciprocal of governing equation. Like in this case, we need to have the x distance, okay, on distance on the x-axis. So that is why the same equation, the same governing equation, reciprocal of this equation. So the function of, now this would be like this one, minus dy by dx is opposite to this equation, but we need here dx by dy as we have to determine x. Okay, so in the numerator there should be the parameter of x. Dx by dy would be, if we say that it is function of xy, and this capital F function of xy would be the reciprocal of the previous equation, and x2 can be determined. So this was the glimpse of the equations which need to be numerically solved to get the flow depth at various sections. Okay. So in both of these methods, our objective is to determine the water surface depth. Okay, you may read the text written in this presentation by yourself. Quickly go to the method which would be used to compute the water surface depth. Okay, let's discuss direct step method, and it has been derived by Chow in 1959, and we call this procedure as direct step method. So in this method, uh, you need to calculate the distance between the two depths. Okay, so it is uh, when uh, when y is known, but you need to calculate x. Okay, so what is this equation? Z2 minus Z2 is equal to Z1 minus S naught. So these are actually the equations. Yeah, bed slope. So bed slope can be calculated. You have so if I say that the bed slope is S naught, then and Z1 and Z2 are known to you, can you calculate? Uh, okay, if Z1 is known to you, can you calculate Z2 if you know S naught? So it is actually
Yes, ma'am.
the it is actually the slope of this line. Okay, Z2 minus Z1 over X2 minus X1 is actually S naught. This we have discussed in the previous lecture. So you can calculate Z2 through this formula, and then E1, you know E1 and E2. E1 and E2 are actually the depth plus the velocity head. You can say pressure head plus velocity head. Or there is another name for this energy. It is specific. It is called as specific energy. So this specific energy is actually the pressure head plus velocity head. Here also, E2 would be pressure head, Y2 plus velocity head. Okay, just check the slide, and there are different methods to get the slope of the energy line, and average frictional slope is this frictional slope is the slope of the energy line. And then you can calculate it by taking the geometric mean of those two slopes. By two slopes, SF1 and SF2 can be calculated using the depths at the at section 1 and section 2 respectively. Okay, SF1 can be calculated using the Manning's equation or Chezy's equation. Any empirical equation can be used to get this slope, and this can be calculated using uh, the so SF1. There would be two slopes here if we consider two sections. So for section 1, the slope would be SF1, and for section 2, slope would be SF2. So you'll be taking mean of the two slopes and get the uh, and you will be using it for the next step. Okay. Usually, average frictional slope would be is used uh, in direct step method. And you know that frictional head loss can be calculated using slope and distance delta x. So again, same figure I'll be taking here. Let me uh, connect this up. Okay, let me check it. So just check these equations and let me know if there is any question. So we have the time available. Okay, I have to open this side again. एक्चुअली मैं कलर्स देखना चाह रही हूँ, आ नहीं रहे कलर इस पे। दोबारा मैं खोल के देखती हूँ, शायद इसका कलर। Okay, this is very simple method. In this method, you need to find y at specified. Sorry, is this correct? You need to find x at specified depth. So which is this you need to find using this method. So, and this is called as direct step method. So, and first equation you'll be using this, and the second equation, this equation would be used to determine head loss. The second equation is the energy equation. Okay, this is the same equation which has been shown in the previous slide. And then the final equation, you can directly use this equation. This is the result of above three equations. Okay, so through this equation, and this is uh, uh, the equation for direct step method, you can easily find out x2 distance. Let's check one example. The slope of this you'll be doing it after this lecture, but let's discuss it. Then you'll do it after I'll be discussing another method with you. Okay, so this would be considered as your assignment 3. The slope of a stream of rectangular cross section. Given parameters are S naught in width, in the width, and width is also given, and the value of the Chezy's constant is given. Find the depth for uniform flow. Like you need to find out normal flow depth. Uh, and this discharge is given. Small q is given 101.54 cusecs per foot, means that it is uh, uh, small q. Small q is actually capital Q divided by B. Okay, so you are given with q, which is q over width of channel. You are given with the bed slope, S naught is given. And width is given, it is 170 feet. If a dam raises the water level so that at certain distance upstream the increase is 5 feet, how far from this later section will the increase by only 1 foot? So they say that there is a dam which is constructed, and at upstream of the dam they have uh, given us the depth upstream. Certain distance upstream, the increase is 5. So they have given us the value of increase in depth, and increase in depth from the normal line, from the normal flow depth. So they say that certain distance upstream there is an increase in depth of 5 feet, and there is another section in which increase in depth is 1 foot, and they have asked you to determine the length between length between y naught plus 5 feet and y naught plus 1 foot. Okay, so just think about it. I'll be coming back in a while. So in this question, first step is to determine this depth, why not, so that you would know that what is the total depth here and what is the total depth here, as you'll be inputting this total depth in the formula to calculate this length. So there can be you can just divide this reach in between these two depths into number of different different reaches. Like you may say that uh, from this depth to this depth, you can take 4 reaches in between, because they have asked you, they have demanded to solve this question after dividing this into number of reaches. Use reaches with 1 foot depth increment. So in the question they have given you this information that you have to use 1 foot depth increment. So first step is to calculate the normal depth. So normal depth is being calculated here using Chessy's formula. You can calculate normal depth. So y naught is 19 feet. So the rest of the steps you will be doing yourself as an assignment. Let me discuss that those steps, and then we shall move forward. So if normal depth is 19 feet, so you have to calculate the distance between the depth which would be 24 from depth 24 feet to 20 feet. So the total depth here would be depth of water surface would be 24 feet here, and here it would be 20 feet. So depth varies between 24 to 20. So and you know this depth is varying up on the upstream side. Okay, so let's check the steps. So you'll be taking 4 reaches for gradually varied flow y1 to y2, or you can say y2 to y1 or y1 to y2. So this is upstream depth, y1 is the upstream depth, and y2 is the downstream depth. Okay, so just calculate all these parameters. Like if you want to calculate the slope, okay, then you need to calculate all these parameters. Slope of the energy line would be calculated like S is the slope of energy line, and so you need to calculate the mean of the slope of energy line. So for that mean, you need to calculate the mean velocity and mean hydraulic radius. So it will automatically, using mean velocity and mean hydraulic radius, you will get mean of the two slopes at the two depths. Okay, so just follow these steps of table, and then you'll be having the result. And then you'll be having delta x for each depth value at 20 feet depth, 21 feet depth, 22, 23, 24, and finally to get the distance between the depths 20 and 24, you'll be adding all these depths and you'll get the final distance. So this is actually the direct step method. Any question regarding it? Please let me know.
Ma'am, do we have to solve this manually by hand, or we can also solve this on Excel sheets?
Yes, it's your choice. You can do so, but for the time, as an assignment, kindly you may just copy those results on the paper, please. I'll say that.
Okay, ma'am. Ma'am, I have
solve it on the Excel sheet and just copy. And if you can attach the Excel sheet, it would be very very good.
Okay, ma'am, sure.
But you have to copy the answers from the Excel sheet in this table manually. Okay.
Okay, ma'am.
So it would be very nice of you if you also share the Excel sheet. So it would be also beneficial for me also.
Ma'am, can you kindly switch to slideshow mode? The slide will be more clearly visible that way.
Okay.
Thank you.
So let me know if there is any question, and it's a very easy method, and you can easily calculate the distances using the flow depths through this method. So in exam, you would be either giving 3 or 4 reaches in between, and you would, or either you would be given to calculate the distance using one reach. Okay, so or using two reaches, we will be asked uh, to calculate the distances uh, for the number of reaches. Okay. Okay, since this in this with Chessy's constant, so you need to use the Chessy's formula, and this is written. Chessy's formula is written here. Okay, to get the slopes or to get the yes to get the slope. So to get S, you need to find out the mean velocity at the two. Like for 20 and 21, you'll be having two velocities for 20 and 21, and get the mean, and then get hydraulic radius mean, and then you can get slope using the mean values of the velocity. Okay, there is another question you'll be doing after this lecture, and this is just check this question. This is the similar type of question, but uh, in this question you'll be using Manning's equation to solve for S. Y naught is already calculated. Okay, the same type of question, but in this question you would have to use the Manning's equation. So some of the calculations has already been done. Just using the specified depth, calculate the delta x value. If a dam raises the water level so that at certain distance upstream the increase is 1.5 meter, how far from this later section will the increase be only 30 centimeter? Use reaches with 30 centimeter depth. So first of all, in this question, you need to find out normal depth, and then you just need to find out the depth at the two sections which are the two sections are given, and then follow. यहाँ पे ये गलत लिखा हुआ है, you need here meanings as Chelsea, sorry, because of Chelsea's formula is used here, not meaning. We also use Chelsea's formula. Okay, let's discuss another method which is called as standard step method. The book, kindly check that example also, and it is similar to the questions we just have discussed. So, the other method which is used to determine the flow depth, it is called as standard step method. The procedure described in the previous section is not suitable if we want to determine the flow depth at specified locations, or if the channel is non-prismatic, that is, channel cross-section and bottom flow vary with distance, and the channel cross-sections are available only at some specified location. Okay. In such cases, the procedure described in this section may be used. And this method is called the standard step method. Since this name has been widely used, a popular computer program, HeadCrash, developed by Hydrologic Center of Engineers, is based on this method. Okay, HeadCrash is based on this standard. So, how can we remember these steps? Let's Let's take the example of this question, and then we'll be discussing this example, and I'll let you know that how to proceed for this method and how to remember this step. So check this question: a trapezoidal channel having a bottom slope of given is carrying flow of 30 meter cube per second. The bottom width is given, and the side slopes are given. At the downstream, a control structure raises the water depth to 5 meters. Determine water surface levels at 1, 2, and 4 km upstream of the control structure. The naming N for the flow surfaces is given, and the elevation of channel bottom at the downstream end is 0. So, give me a minute to understand. Okay, they have asked us to determine the water depths at different distances: 1 kilometer, 2 kilometer, and 4 kilometer. So uh, it means that we will be dividing the whole reach into number of sections, number of sub regions, and let's let's draw the figure line diagram for it. The method is called as
Excuse me, ma'am.
yes.
Ma'am, slide stuck है मैम 13 स्लाइड है
Slide stuck है?
जी मैम आप 13 स्लाइड पे हैं मैम या कहीं और आपने शिफ्ट किया मैम
मैं तो 22 स्लाइड पे हूँ
मैम वीडियो में आप तक 13 ही दिखाई दे रहा है
अच्छा मैं दोबारा शेयर करती हूँ
मैम बाकी सबको 22 ही शो हो रहा था इनका इंटरनेट स्लो होगा
अच्छा आप रीजॉइन कर रहे हैं ठीक है क्या नाम है आपका
मैम जरा मैं रिजॉइन करता हूँ मैम
हाँ जरूर आप रीजॉइन करें Okay, the method is standard step method. And in this method, you need to find out the flow depths at specified locations. Okay, so let me draw the line diagram. So I'll be silent during that.
एक्सक्यूज मी मैम, अनम्यूट करें अपना माइक।
एक्सक्यूज मी मैम, आपका माइक म्यूट हुआ है।
एक्सक्यूज मी मैम,
Okay, according to standard step method and using this figure, you can calculate the depth at various sections using two equations. Okay, so if this first section, which is at x naught distance, like if the from here to here it is x naught, and this is known to you at x naught, the these values are known to you. Okay, this is these values are given in the question, like z naught, y, and then through through y, you can calculate v square over 2g, and so you can say that H naught is known to you. H naught is the total energy at this section is known to you. So it would be Z naught plus Y plus V square over 2G. Okay. So this is known, and this would be known to you. Either you would be having you would be calculating the velocity using the depth value, and you can know the energy head at this section. Okay. So the next after calculating the energy head at section whose parameter can easily be calculated using the given parameter, whose unknown parameters can be calculated using the given parameters easily. So after having the total energy at this section, you would have to calculate the total energy at section 2, as your objective is to get this step. Your aim is to get y1, y2, y3, and y4. In standard step method, you are given the distances, but you are not given with the depth. This you have to calculate. So you can calculate it using the equation. Okay, to get the energy at section 1, what would be the equation? H1. If I need to find out H1, it would be Z1 plus Y1 plus V1 square over 2G. Isn't it? So this is the total energy at this section. Okay, and this this total energy can be determined in different ways. Like you can calculate using this equation, and H1 can also be calculated using another equation, which is H naught plus HF, HF1. Just check this. Can H1 be calculated using H naught plus HF1? H naught is the total energy at section 1. So H1 is from here to H1 is from this point to that. So this is H1. And similarly, H2 would be from this point to that. This is H2. Okay, so this H1 can be determined using this equation, like Z1 plus Y1 plus V1 square, and the same H1 can be determined using the known value of H naught would be from here to the bottom. This is H naught. Okay, so H naught plus HF1 would give you H1. Okay, so there would be two equations which you can use to find out H1. Oh, sorry, Y1. First H1 and then Y1. So in this method, how can we use these two equations to get the energy at the same section? We will be assuming the first step is to assume some value of y. Assuming y. Okay, this is the first step. And through that y value, you can calculate the you can calculate H1 and V1. If you know Y1, you can, assuming Y1, you can calculate the parameters involved in equation 1. Okay, so Z1 can be calculated using the bed slope given. S naught is given to you. So if S naught is given, then you can calculate Z1. Okay. Then Y1 is assumed, and V1 can be calculated using Y1. So first step is to assume Y1 and calculate H1. Okay. And the second step is to get the values of HF1 and then use that value of HF1, add that value to H0, and then you can get H1 again. So there would be two values of H1 for one value of Y. Okay. So how would you get, do you know about HF1? How would you calculate HF1? So for HF1, you know that head loss would be the slope. Head loss is, if you know the slope of the energy line here, SF1, mean slope of energy line here, then you can calculate HF1. Okay, so HF1 is what would be its formula? HF1. Second step is to find out frictional head loss. It would be equal to SF1, which is the mean slope between this point and this point, SF1, multiplied by delta x, distance between the two, isn't it? Delta x would be SF1 multiplied by x0 minus x1. Okay, so this distance is this. SF1 is the mean slope. Okay, and mean slope can be calculated using the average of the slope, calculated through the values of depth at the two sections. Okay, so any question up till here? So after calculating HF1, you will be adding HF1 with the H0. H0 would be known to you, is the constant value. Okay, then you would be having two values of H1. Okay, third step is find H1 using the equations. And fourth step is compare the two H1. Compare the H1 values. Okay, so these four steps would be followed in standard step method. But you will be getting the Y1 using these four steps, and then you have to repeat these steps again for Y2 and Y3 and Y4. So for Y1, for your assumption, the value you would be assuming for Y1, you will be doing all these calculations. Okay, so and then after at the end you will be comparing the head calculated through these two equations, and if the difference is within the tolerance limit, then it means that your assumption is correct. Otherwise, you have to re-assume and calculate again all these values. So this is the iterative process, and if the H1 calculated through both equations are different, then you have to okay, and then calculate again. So similarly, you'll be proceeding for the rest of the Y values. Every time you'll be following all these steps. Like you for Y2, first assume Y2 and then calculate HF2. HF2 would be this head loss between section 1 and section 2. Okay, so HF2 would be calculated using SF2 multiplied by delta x in between the section, and then find H1 using the equations. Since all the parameters would be calculated, then you can find H1 and H1 using these two equations and then compare. Any question, please? Can you do that? Any question? So you just need to learn or remember these steps to do standard step method. Yes, it is iterative process, but and it is cumbersome also to assume for y, and then to have the same values of h1. This is actually you have to think. Okay, there is one question in the book which we check. This is solved example in the book, and can we check this question? It has been solved in the book by. Do you have the book with you? It is Open Channel Flow by Muhammad Hamid Chaudhry. Do you have it? Or soft copy? If anybody has soft copy, please send it to me. I'll share it with the rest of the class. Or kindly please share it with the rest of the class so that they can read that book. Who is the CR?
मैम कमर नियाज भट्टी।
कमर आप शेयर कर देंगे, मुझसे भी शेयर कर लें और बाकी क्लास अपने क्लास फेलो से भी शेयर कर लें, स्पेशली जो स्टूडेंट्स ये जियोटेक ग्रुप के हैं ना, उनसे ज़रूर शेयर कर लें और उनको गाइड भी करें कि कैसे अगर बता सकते हैं उनको बता दें कि क्या उनको जो भी मसला हो रहा है तो आप गाइड कर सकते हैं। कोई भी गाइड कर सकता है जिसको बेहतर समझ है, लेकिन अगर क्या नाम है उस स्टूडेंट्स का जो कि जियोटेक डिपार्टमेंट के हैं? प्लीज लेट मी नो। आई मे वॉच, आर दे प्रेजेंट?
यस मैम।
ओके, आपको समझ आई है कैसे करना है, हमने कैसे सॉल्व करना है?
ट्राई तो कर रहे हैं, अगर जो ना आई तो फिर रिकॉर्डिंग भी देख लेंगे मजीद।
नहीं, आप मुझसे भी पूछ सकते हैं, आप ईमेल कर लें या किसी और दिन मीटिंग भी कर सकते हैं या व्हाट्सएप आप मुझे कर सकते हैं, ठीक है? मैं नंबर शेयर कर देती हूँ।
ओके मैम।
वो आप ये जो एटलीस्ट जो प्रेजेंटेशन में क्वेश्चंस हैं उनको करने की कोशिश करें अच्छी तरह, उनकी प्रैक्टिस अच्छी तरह करें, ठीक है? चलिए, थैंक यू सो मच। दैट्स ऑल फॉर टुडे। इफ यू वुड हैव एनी क्वेश्चन रिगार्डिंग टुडेज लेक्चर, you can always send me an email, you can send me the message. I'll be sharing my number with you, but try to solve first by yourself and then ask anything you need to ask, okay? So
ये असाइनमेंट कब सबमिट करनी है?
ये असाइनमेंट कभी करनी है? You won't be wasting your time of class. ये क्लास असाइनमेंट है, तो ये अभी आप करेंगे?
मैम नेक्स्ट वीक कर देना मैम।
मैम अभी मुश्किल हो जाएगा।
जी मैम, और भी बाकी भी काम है हमारा मैम।
क्या काम है?
मैम नेक्स्ट जो हमारे एक आर्टिकल रिव्यू भी सर ने हमें दिया हुआ है मैम, जो सर अहमद ने मैम, वो भी काफ़ी लंबा है मैम। उन्होंने कहा कि एक प्रोफेशनल एक रिसर्च ले लें और उसको रिसर्च करें, ताकि पहले लिटरेचर रिव्यू करें फिर उसके बाद उसके क्रिटिकल रिव्यू करनी है मैम।
अच्छा, वो तो ठीक है, वो तो आप करेंगे, लेकिन ये अभी टाइम तो इसका है ना, रिवर इंजीनियरिंग का, तो आधा घंटा आप दे दें और ये क्वेश्चन बस ये वाला क्वेश्चन करके मुझे जमा करा दें, ठीक है?
मैम हम ट्राई कर लेते हैं, लेकिन इसको आज ड्यू ना करें मैम प्लीज,
जी मैम।
कल या परसों तक का टाइम दो।
तो ये टाइम अभी आपने इसी पे रिवर इंजीनियरिंग का काम करना है, ठीक है?
मैम हम इसको क्वेश्चन को ट्राई करते हैं, अब जो है ना वो नीटली तो अब नहीं होगा, इसको अंडरस्टैंड करने की पूरी कोशिश करते हैं।
तो इसमें तो कोई ऐसी चीज नहीं है, इसमें ये वही सॉल्व चले, ठीक है
मैम, वो फिर भी अपने यहाँ पे देखना पड़ता है इसको डिटेल से।
अच्छा ठीक है, लेकिन आप अभी यही करेंगे, मैं आपको एज क्लास असाइनमेंट दे के जा रही हूँ। सबमिशन कभी भी हम बाद में रख देंगे, ठीक है? सबमिशन ना करें, सबमिट ना करें, लेकिन आप अभी ये सॉल्व करेंगे, ठीक है? डोंट वेस्ट योर टाइम, इस टाइम को कंज्यूम करें, ठीक है? थैंक यू सो मच। और ये खुली हुई स्लाइड मैं थोड़ी देर बाद आके चेक करूंगी और अटेंडेंस दूंगी, ठीक है? थैंक यू।
मैम अटेंडेंस
अच्छा, ये मैं प्रेजेंटेशन शेयर कर रही हूँ, तो वो आप ओपन कर सकते हैं अपने उस पे। मैं ये प्रेजेंटेशन शेयर कर रही हूँ। ओके, मैंने शेयर कर दी है, तो आपकी अटेंडेंस फिर मैं थोड़ी देर बाद लेती हूँ। 7 o'clock में आपकी अटेंडेंस लूँगी, लेकिन मुझे इसका भी फीडबैक चाहिए, इस क्वेश्चन का। जो भी क्वेश्चन होंगे इससे रिलेटेड तो हम अक्सर डिस्कस कर सकते हैं, ठीक है?
ठीक है मैम।
Okay, please let me know if there is any question.
मैम ये फर्स्ट पार्ट तो हो गया है, लेकिन सेकंड पार्ट अभी एक्सेल में बना रहा हूँ मैं।
अच्छा ठीक है, वेरी गुड। तो आप काइंडली शेयर मुझसे कर दीजिए वो एक्सेल की शीट भी, ठीक है?
ठीक है मैम, अभी तो वैल्यूज पुट कर रहा हूँ मैं।
ठीक है, वेरी गुड।
एक्सक्यूज मैडम,
जी
मैडम ये वी बार और ये आर बार जो है ये बेसिकली अरिथमेटिक मीन है जो हम डिफरेंट सेक्शन के ऊपर वेलोसिटी और हाइड्रोलिक रेडियस फाइंड करेंगे।
जी जी बिल्कुल। यहाँ पे आपके पास हर डेप्थ के अगेंस्ट 2 वैल्यूज आएंगी ना वेलोसिटीज की। तो समझिए ये v1 यहाँ पे आई और यहाँ पे इस डेप्थ के v2 आ गई। तो ये v बार जो है दैट वुड बी v1 प्लस v2 ओवर 2। ओके, वो इन दोनों की वैल्यू होगी, एक वैल्यू होगी, यानी हर 2 वेलोसिटीज v3 के दरमियान एक वैल्यू होगी और फिर v3 और v4 के दरमियान एक वैल्यू होगी। ठीक है, तो इसी तरह आपके पास 4 वैल्यूज आती है मीन की। और इसी तरह हाइड्रोलिक रेडियस की भी मीन हाइड्रोलिक रेडियस यहाँ पे r1 और r2 होगा। तो मीन वुड बी r1 प्लस r2 ओवर 2। तो जब आप इनसे वैल्यूज कैलकुलेट करेंगे वो अरिथमेटिक मीन ही से निकलेगा, यानी इन वैल्यूज को आप यूज करेंगे स्लोप निकालने के लिए। तो ऑटोमेटिकली वो SF1 प्लस SF2 ओवर 2 ही होगा। ठीक है, तो पहले ही आप अगर मीन निकाल लेते हैं, या ये स्टेप आप बाद में भी कर सकते हैं, SF फिर निकालें, उसके बाद उस SF का मीन ले लें, एक ही बात है, एक ही रिजल्ट आएगा।
राइट।
Okay, I expect that all of you would solve the questions which are given in the presentation. हाँ जी
मैम इक्वेशन 10.38 के फ्रिक्शन स्लोप की एवरेज है।
इक्वेशन ये वही चेज़ीज़ इक्वेशन निकालेंगे ना आप। ये चेज़ीज़ इक्वेशन S की वैल्यू आपने निकालनी है ना, यूजिंग मीन वेलोसिटी एंड मीन हाइड्रोलिक रेडियस। तो वो ये इक्वेशन होगी, कैसी इक्वेशन होगी 38। ये बुक का इक्वेशन नंबर लिखा हुआ है। तो कैसी इक्वेशन? Okay, thank you so much. Let me download your attendance, then you'll be free to leave.